And the first step to these problems is to see if you need to do long division. You need to do long division if the degree on the top is equal to or more than the bottom. So this was not a long division one. The degree on the top is smaller. Okay. Then the next step is to factor the bottom. And the factorization of the bottom on this one is a little bit challenging. This one is difference of squares. It's a perfect square. Any even power is a perfect square. Minus a perfect square, right? 9 is a perfect square. 3 times 3 is 9. So I would say, okay, this factors into x squared plus 3 and x squared minus 3. I don't rewrite the entire problem here, but that's my two factors. If this number was a perfect square, I'd factor this more. It's not factorable anymore because we don't use roots or imaginary numbers or anything like that. Okay, we're trying to make these into smaller, less complex fractions, and so writing like x minus root 3, x plus root 3 is certainly not going to make this problem easier. And so you wouldn't do something like that. Okay, so that's factored as you're going to get there. And then you write two fractions, the two fraction one. Any questions so far? We said that the thing that goes on top of this fraction has to be a lower degree than the bottom. So the thing that goes on top of that fraction could be a number, or it could be a linear equation of first degree. We don't know which one it is. So what we do is we just assume that it is going to be linear, and it might turn out just to be a number. So we're not going to write down A. We're not going to do it like that. We got to write down a linear equation. So we write AX plus B. Then you might say, well, that's 1 degree lower. Well, A could be 0. Okay, so if A is 0, then you'll just get a number for B, and it will be 2 degrees lower. Oh, if you do get a number for A, then it'll be 1 degree lower. So the thing that goes on top is at least 1 degree lower than the bottom. It could be, 2 degrees lower or 3 degrees lower on some problems, but that's what we're going to write there. A could be 0, B could be 0. They won't both be 0. If you get A and B to be 0, something's wrong. One of them will be 0. And then we do the same thing on this one, CX plus D. Be really careful with your D's, because if you look at what I wrote there, you can see how somebody could think I wrote x plus 1 in parentheses. Do you agree with what I'm saying?
Yeah.
Okay. So, trust me, there's certain numbers that are dangerous in math, okay? I can't tell you how many times I've written a 13, and people are like, why did you write a B? And, I didn't know, and the problem has nothing to do with the letter B, and people ask, why does it say B? So, be really careful with your letters. The C looks like a parentheses, and the D could look like a parentheses if you're messy, so just be careful. All right, any question about that setup right there? I promise you we will practice these setups a lot, and so if you're a little unsure about the setups, we're going to practice that more, but let's just keep going here. All right, so the next step after this is to multiply by the common denominator. The common denominator is not something you have to think about, it's this. That is the common denominator of all the fractions. And if it's not the common denominator, then you did something wrong. So we're going to multiply both sides by x squared plus 3 and x squared minus 3. You don't have to think too hard about this side, because whatever is right there, that's what this is going to be. The top of that fraction is what that's going to be. And the reason is these two things will cancel this, because the common denominator will cancel all the denominators. It always does. You really have to be a person who does a good job with parentheses here when you do this, because you have to multiply both of these things times this fraction. Oh no, let me get rid of that. Oh boy. Try it again. Both of these things need to multiply the top of this fraction. So the top of this fraction, you're going to have an a plus b, an x squared plus 3, and x squared minus 3. The x squared plus 3's cancel. So it's going to be a plus b, put it in parentheses, times a x squared. Is this one a minus 3 or plus 3? Minus 3, because the x plus 3 is canceled. Okay? You try to do the next term on your own before I do it. I want that to be blue. If you have questions about this, don't be shy. Ask me what the questions are because there's a lot happening here. So when I multiply this one by the top of the fraction, I have a c plus d, I have an x squared plus 3, and then the other two things cancel. So this one is going to be cx plus d times x squared plus 3. Now, I made a mistake on purpose, okay? What is wrong with what I just wrote there? There's no parentheses, okay? You've got to have the parentheses. It's different, with or without the parentheses. So you put parentheses around that. And like I say, you got to write neatly because those parentheses and the C's and the D's all look kind of the same if you're really a messy person. And so, it's not a matter of whether I can read it or not. It's whether it matter you can read it or not when you're doing the problem. Okay, now, is there a letter or not a letter? Is there a number that you can use for x that will get rid of 3 of the 4 missing letters? We have an A, a B, a C, and a D. Is there an x value that will get rid of 3 of them? 0 would get rid of A and C, right? But it would leave B and D. Is it even possible to plug in a real number and make this 0? No, there's not even a number that makes that happen. X squared is either 0 or positive, and you add 3, you get a positive. That value is always positive. That's not going to happen. The number that makes this equal to 0 is root 3, and that would be great. It would make that would make that go away. But then you'd have root 3's all over the problem. That's not going to make that a lot of fun. So this is an example of a problem where that shortcut is not going to work. Okay? So we have to use the other method, the system of equation method that I have not shown you yet, but I'm going to show you right now. This system of equation method will always work. All right. It takes a little getting used to. It's actually a very logical thing. It just takes a little bit getting used to. We actually have to multiply all this out. Okay? So let's do that. So I'm going to just rewrite x squared, 3x squared minus 6, and I'm going to do multiplying these binomials, what people call FOIL. This is ax cubed. I'm doing this one, minus 3ax plus bx squared minus 3b. You could try to get ahead of me here and multiply that one out. And by the way, you can use any letters you want. Like I used A, B, C, D. You can use any letters you want. If C's scare you, then don't use C's. Okay, check it with mine. So I multiply those out. Now, I want you to imagine that there weren't A, B's, and C's, and they were just numbers, okay? If I had numbers here and I multiplied this out, and then I had numbers here and I multiplied this out, I'd have these 2 polynomials, and the next thing I would do is add like terms. And that's what I'm going to do right now. I'm going to add like terms. They're just these like terms are going to have a bunch of letters in them. So I'm going to underline these 2 because they're both x cubes. I'm gonna double underline these two because they're both x squareds. I'm gonna triple underline these x's. And then, you could quadruple underline, but it gets a little bit crazy. So I'm gonna be fancy here, and I'm gonna do a zigzag underline for these ones, okay? You could use different colors, you could circle them, you could do whatever you want. Just know that you're adding like terms right now. Now, I don't know what A is, and I don't know what C is, but I do know that if I was going to add these two things, I would add the A plus the C, and that's what I'm going to write out. I would say I would add A plus C. I'm going to put that in parentheses in front of x cubed. So A plus C goes in front of x cubed. Okay. So you guys tell me, what goes in front of the x squared? B plus D. Imagine those are numbers. If those were two numbers, you would add them. So bx squared plus dx squared is b plus dx squared. Sometimes people think of that as like a GCF, like you have these two terms and you're pulling out an x squared. That's kind of like what adding like terms is doing a GCF. All right, then I have to do these triple underlined ones. So I'm going to write plus here. I usually don't write minuses. And I'm writing negative 3a plus 3c goes in front of x. And then negative 3, I messed up. Negative 3b and 3d are the constants. Remember, B and D and A, B, C, and D are all numbers. Okay, they're numbers that I'm trying to find here. All right. You may not know where this is going, but does anybody have any question about what I did? We're going to talk about where this is going right now. This is a polynomial. If I knew what A, B, C, D were, this would all just be one big polynomial, okay? These polynomials are equal to each other. So whatever this polynomial is has to be equal to that one. That being said, tell me what B plus D would have to be if this polynomial on the right is equal to the polynomial on the left. What's B plus D have to equal? 3. Because those are the numbers in front of x squared. So the thing in front of x squared has to equal the thing in front of x squared. Okay? So now I skipped to that one because it was easy to understand, but let's talk about the first one. So what do you think A plus C has to equal? 0, because over here there's no x cubed.
There's also no x.
There's also no x. So then I'm going to write this over here. We said B plus D has to equal 3. We're matching up the terms. We're saying here's an x squared, here's an x squared. In front of that's a B plus D, in front of that's a 3. So B plus D has to equal 3. There is no x over here. That means that this stuff all has to equal 0. I'm going to write that over here. I'm not writing those like that because of the fact that they both equal 0. Just coincidentally on this problem that I have an A and a C equation, another A and a C equation, and then I have over here another B and a D equation. So what's negative 3b plus 3d have to equal? Negative 6. Okay, so you're literally saying like these terms go with these terms. Now I'm going to write something out to help people who might not have understood that. Okay, let me write this out. 0x cubed plus 3x squared plus 0x minus 6. Okay, so I wrote this polynomial and I just threw some zeros in there. So here's what I'm doing. And I know a lot of you got this already, but I'm saying A plus C has to be 0. B plus D has to be 3. ax plus c has to equal 0, and 3b plus 3d has to equal -6 to make those polynomials equal. Following that a little bit? All right. Now, there's two ways I could solve this system. This one just happens to be an easy one to solve. I could throw all 4 of these equations into one big matrix and solve. Or I could just coincidentally, because of the way this problem is, I could make this into a system and just do that and find A and C. That's an easy system. It's 2 variables, 2 equations, and then separately do this one. So some people would want to do this by hand. They're like, this is so easy, I might as well just do it by hand. And you could do that too. But you got to find A and C, and you got to find B and D. And then once you find A, B, C, and D, then you plug them all in. Does everybody understand where I'm going here? Do you want to do one big matrix or 2 little matrices? You guys have a preference? All right, let's do 2 little ones. Don't want to say anything. Okay, so I'm going to do 2 little matrices. So I'm going to go to second matrix. I know I could do this one by hand because a 2x3 matrix is pretty easy to, or 2x3 system is pretty easy. But I'm going to do this one with the A's and the C's. There are going to be times when you need to do a matrix that is, you know, 4x5 matrix, but I could do it like this. So I did 1, 1, 0, -3, 3, 0, and I'm finding A and C right now. My first column is the A, the second column is the C. What the heck? Did I type in this matrix wrong? Let's try this again. There's no way that's the answer. Wait a minute. 1, 1, -3, 0. I'm doing this right. A and C are both 0. It could be A and C are both 0. All right. Well, let's write that down. Remember I said they could be 0. All right, let's do the B and the D. It kind of makes sense that they're both 0 when you really look at that system. Now these can't be 0. And like I said, I could have solved this one by hand. It's not really that hard to solve, but since we're just learning REF, we might as well use it. Do this. What is my problem, right? -3 and -6. So I got B equals 2, D equals 1. And you can plug those in to check them to make sure that they actually give you those numbers. E. Oh, I actually wrote a wrong letter here. I don't know if you noticed this. That's a B. Sorry about that. That's a B.
I got 2.5 and 0.5.
Okay. All right. What did I do wrong then? I must have wrote something wrong. Oops. All right, what's wrong with my matrix?
Oh, you put
No, I have
0.
a 0 in there. It's just, it's hard to edit on this thing. I'm much more comfortable using a real calculator. All right. Now let's do it again. Okay, 2.5. So let's write that as 5/2. And the D would be 1/2. All right. We're not done with the problem. We found our values there. if you want to try putting this in as one big matrix where there's a column for A, a column for B, a column for C, and a column for D, that's not a bad idea, just so you could see that it'll come out the same. And then a column for the numbers. But these are the two values that you would get out, whether you did this as one big matrix or two separate. It's just coincidentally that this one, you could do two separate matrices. Oops. Let me try to move that again. Having a technical problem here. I am going to get rid of this and make it back to where the way it was. Okay, so now you have the problem of these fractions, which we haven't seen that either. So when I go to plug these values into this thing, the A and the C are 0, and that's okay, that could happen. We're not going to leave it like this, but write 5 over 2 x cubed plus 3, x squared plus 3, I mean, and then 1/2 x squared minus 3. Now, we're not going to leave it like that, but that's plugging A, B, C, and D all in. Like I said, those things on top are going to be a lower degree than the bottom. These happen to be 2 degrees lower. The way you simplify this now is when you have a fraction in a fraction, you multiply by the denominator of that fraction that's in that fraction, the common denominator of the little fraction that's in the big fraction. These are just 2's. There's only one fraction there, so this is the way you would write it. Whether you multiply out the bottoms or not doesn't make a difference. When you look at answer keys, they will not be multiplied out. I think this is the best way to write it right here. And that's the final answer to this problem.